How's it going, ladies and gentlemen? Welcome back to my channel. So in this video, I'm going to talk about struct and interface in Golang. So probably the first thing is, what is a struct? So let's say you have a lot of functions and also variables. So let's say here's the functions and here's the variables. If you're going to write into your function, into your main, for example, actually you need to put it a lot of times. And therefore, this is a key concept for object-oriented language, and that is they have the concept for the object. And in Golang, it is called struct. And also, we need to know another concept that is called the abstraction. So abstraction is like you define a struct. So for example, here you can wrap it together as a kind of struct. And you are able to import this into other classes, for example. So for example, if you have another, let's say here is struct A, and here we have a struct B. Therefore, we can have a lot of other components like C, D, etc. And also, we can have the struct A. And therefore, in this format, actually, we can save a lot of memory and writing time. And more conveniently, we can just change the struct A here in order to change some functionalities in struct B. So this is the beauty for struct. And let's take a look on how to write the code. So let's say we're going to have a struct named cat. So in struct, we can actually declare a lot of variables, for example, the name, etc. And you just have its variable type after it. But here, for simplicity, we just have an empty struct. So an abstract is totally fine because actually, for example, there's singletons. So singletons will actually use the empty struct in order to call another struct. And next, what I'm going to talk about is the method. So method is actually kind of like function, but it's not same as function. So as we know, for the normal function, we can just declare a variable name here. So for example, if I say say and just nothing, and probably I can just print out what it will say. So for cat is like meow. Normally what we are going to do is just we put a say here, right? So this is absolutely runnable. So say here is actually a function, but here what I'm going to talk about is for cat, and to declare it as a method. So you can see here actually it gives a warning that is unsolved reference say, because right here we have to use the cat here. So what we're going to do right now is actually we have a cat, probably we can just declare a cat as a variable here, and what we're going to do is cat.say. Okay, so here you can see actually things are fine here, right? You can see there's no warnings. If I run my main function, you can see it actually says meow. So what if I put an address sign here? So address sign here basically means, okay, so the cat here is actually the address or the pointer for the struct instead of the value anymore. But here if I run it, what would happen? It is still saying meow. So here's the question, right? Why can set the variable cat as either a value and also the address? This is because if you set as the variable here, actually Golang will actually do a transformation for you. So right now, even though cat is an variable, but it will still transfer it as an address. Because you can see here actually I declare the cat as a pointer here. And this will transfer the value of cat into the pointer of cat and call the say here. So for example, if I delete this part, it is still fine. And if I add a part here, it is still fine because even though right now the cat is an pointer format, it will still transfer it into a value format and call this say function. And here we have to notify one thing. In order to call this method, which is say method here, the name or the variable in front is actually optional. It's like you can put it as new. So for example, let's say I just declare this variable, right? As a variable cat, and I make it, for example, as the type here. It is still callable. So let me just run it and see. Yeah, but what if I just print out and let me say cat is what? And let's see. This is actually a point that struck me a lot previously. And you can see here is actually a new. So even though it's a new here, you can still call this function the same methods. I know it definitely doesn't make sense in C++ since a new variable can never ever have any methods to call, But here's the case. This is the beauty for Golang. Since it just doesn't care about whether this variable is nil or not, it will just say, okay, I know this is this type and the type is declared here, and I will just use this type to call this method. Okay, so now we just get back. And what if I want to have something more, right? Probably I can have a doc. Let me just create another type, which is doc here. And I'm going to have a doc, and I also have a say. Oof. What's the sound? Woof? Woof? Okay. Probably I just don't know how to pronounce that. Okay, so later I will also discuss the difference between the value type, which is right now, and also the address type. Since later I will just discuss this in the interface part, so that can more easily to discuss. So what if I have another doc here, and let's say just name it as say1 and say2, right? Just to make it clearer. And probably I can have a doc, define a doc here as well, and doc, and I can also have doc.say2. Okay, and if I run it, not surprisingly, I will first call meow, and next is what. Okay, so this is what actually we are expecting. So now I would like to talk something more advanced, and that is called the inheritance. Inheritance is very common, right? If you want to do something easily, actually you need to use the inheritance. So let's say, I know I can define a lot of variables here, but to just make it clearer and simpler, I will just insert another type, struct type here to illustrate inheritance. So here actually is still very simple struct here, that is cat. And cat, it has another type. You can see the color is different, right? It's not white, but this kind of blue and green color. So this doc is actually, you can see, this is a type of doc of struct, and that is here. So in struct, actually, you can include the definitions for other struct, and in interface, you can call and also define other interfaces. But in struct, you can't call interface, and in interface, you can't call struct. So that is very strict. Okay, so now what if I want to do something? Probably, let me just cat A. What if I just want to do something? And you can see here, actually I can define it a doc. And here it is called a type transformation. It is because previously this type is actually cat, and now I'm going to transfer it into a doc type. Printf. I can show you some magic. And if I put value here, and I can just have cat A and cat A here. Probably I can also include it into some other parts as well. Doc, okay. And here just put cat, doc, and let's just run it. So first is meow, which is the cat here. Then we're going to print out something, and that is the type, and that is the struct of cat, and the value of cat, that is nothing. Probably I need to put a break line sign here to make it clearer. So again, we can see here first is meow, which is what it called here. And next, the type is the man.cat, since it is the man package. And also we have the value that is empty. And for dog, first we have a wolf, which is say here. And next we are going to have the similar stuff. And not surprisingly, here we actually got the man.dog. So here, a few more things. First is, since cat here is actually defined as the struct here, so when you call another stuff, which is .dog here, it would automatically think, okay, this is the variable type. This is not the address or the pointer. So if I add and pointer here, actually it will say, here we have a star sign here. Probably you would like to ask, like, what's the usage or the implementation for this kind of struct with a struct in another struct? For example, if I just define cat here, right? And for cat A, or probably I can just put cat, You can see. So now probably I can just delete this sign here. So the beauty of this kind of struct in struct is you can actually transform a particular struct, which is the cat here, to other methods. So previously we can just see here it just has say1. Probably I can just temporarily delete this part. And actually I can do say2. You see? This is amazing, right? So what does this say2 mean? This is basically mean I will first transfer my cat into the dog type, and I'm going to have say2. So you will see actually these two results are basically the same. And if I run it, should be meow and then both wolf. Okay, cool. So this is the beauty for the inheritance. Because even though you just create one cat here, right? You can actually call the methods from dog as well. Okay, cool. I think this is about the struct here. And next, I'm going to talk about interface. So what does interface mean? Interface also, I'll start with the type, and let's just say interface. So interface will actually include the methods or the functions. So actually here we won't put define struct in front, because it will just have a very simpler term. So if I have any return type, I will add here. But since I have nothing for return, I'll just put it here. I just don't include any of the front part because I just want to make it as simple as a function. So if I say it as a say1, so here I just remove that redundant part, and I just have the cat in front. So what I want to do is I want to define another variable, and that is animal with the type of interface, and that is say here. Okay. So next I can give the value for it, and if you see the say here is a type of interface. So the beauty of interface is actually you can put any values for the interface. So for example, I can put either int, for example, like a variable, and also the struct as well. So probably here I can put a dog, D-O-G, okay, oh sorry, cat, which is the variable here, and I can call the animal dot say. Okay, let's just run it. And no doubt that is meow for the cat. Okay, so what if I delete this sign here, the pointer sign here? If you remember previously when we talked about the struct, actually we can just delete this part, and if we call cat.say1, we can actually still call that. That is because Golang did the transformation for us. But what if I delete here and assign this value to my interface? Actually, it will say something. It says say1 method has a pointer receiver. So it says it has a pointer receiver, but now we actually give a variable receiver, and therefore we have to put a pointer. So for example, I can put either assign there and assign there, but usually I'll just put it here. Okay, so another thing I would like to talk about is the interface. The value assigned to the interface must include all the methods or all the functions that are declared in the interface. So for example, here I have my cat here, right? So cat only has one method that is called say1, and say1 has already been declared in this interface. So what if my interface, I would like to say, okay, I want to have two of them. And if I run it, you can still see, okay, I have a meow. But what if I delete this part? And you can see this can be used cat, type cat, pointer cat as type of in assignment, since it does not implement say. The say2 method has missed out. It is because in cat struct here right now, it actually doesn't have or implements any say2 functions. So there will be some issue. But the reason why previously, when I have the dog here, right, I have this dog struct here, it has no error. That is because since I can actually call my say2 by using, for example, animal, I can actually call say2 because I already have a struct of dog here, right? And I can use dog struct to call this method. So that makes sense. And here, to make it clearer, I just want to make it both as say as I think there is more important thing I would like to talk later. So just a little bit knowledge for the format. So usually the interface will be put before struct, because interface is more superior, and we just want to make it at a place that when you first open the file, you'll see it. And usually the interface, if it only has one function here, which is say here, it will actually put an ER at the back. So for example, say here, it is definitely fine. Like if your interface has no function defined at all, that's totally fine, same as struct. Okay, so now probably I need to do a little bit changes. So say, and another thing I would like to mention here is if we define this as a type of interface, which is the animal here, and we just have the sum values for the say for different types. So this sum method, though called in different struct, this cannot be accessed by the interface anymore. So you can have, like for example, dog something, right? It's unlike struct, cause dog here just can't be accessed anymore, cause their methods here defined in the same way, which is called say. But for example, if you really want to call another method for a different struct, yeah, you can call it like say2, and you just put it here. For example, say2, it is still accessible. So animal say2, you see here we can still access say2. But here for simplicity, I just removed that part. So here is a summary. If you have similar methods called by the different struct, actually if you define them into the identical way, and you can't access by a particular interface anymore, you can only be accessed by the struct. So for example, I can have cat, I can first make it dog, and if I call it say here again, then it is for the dog wolf instead of meow. And perhaps here you would like to ask, like, okay, why we need this kind of interface, right? Previously, we used the struct to call all these methods. That is fine. And now we have to define another variable, which is an interface type, and to call the methods again. So why we need that? Okay, so previously, I believe I mentioned the beauty of interface is it can access or assign by anything. So here, I would like to give an empty interface, okay? So variable, let's say test, and I have an interface. So here actually I can give any kinds of values. So I can give you, for example, integer type like 1, and also I can give string type like anything. I can assign anything here. So let's say I first just assign 1 here, and if I would like to print it out, let me comment this part first. Println test. Okay, and you can actually see here is 1. Then probably the next question we have is, okay, I know interface can be assigned with any type of values, but why we need kind of interface, right? No matter what kind of value we assign, we just don't care. So next I would like to introduce is the type switch. So I can first remove this part, and I can just switch. Switch here is not, the computer games, alright? It's not dot switch, but yeah, it is called switch. And we can have case. So let's say, so actually this is type switch. So we need to have a type here. If we just have a value there, then it is assigned by value. But if I have dot bracket with type, so we actually define by the type here. So actually here we can assign, so let's say if this is the case of int, we just print like int. If it is string, then we can just put it as string. Okay, and also I can have default, right? Default. And I can say no idea. Okay, and if I run this part, oh, there's no case here. Should, okay, and it should return the type of int, cause here the 1 is actually written as type of int, and you can see, okay, it's correct here. It is int. Great. So probably the next question we would like to ask is, Okay, I know interface can be assigned with any values, and I can find a type for the interface. So what the heck is exactly the usage for this kind of thing, alright? Okay, I think I've talked too many things, but this is very useful during a function define. So let's say we have a function testing, and we can have, for example, a variable, and that is in type of interface. No, I can't variable. Okay, this is fine. And I can put my chunk here into the function. So actually here we can actually define this kind of type switch. So we can know what kind of type for the interface, and we know. So in traditional functions, right, we have we just have the type of like string, int, etc. But this kind of input arguments are actually fixed. You can't change as long as it is defined. Therefore, in the future, if you want to change this function, if you want to have other kind of arguments into it, actually it's kind of troublesome since you have to redefine a function. Therefore, in the early stage, yeah, if you can define this variable as the type of interface, actually this is very flexible. So this is the beauty. So after we talked about the type switch, one more thing just about the interface, and that is assertion. So assertion is like, okay, I would like to assert something, right? So here we can actually type out the test. So sorry, it should be up here, and I can have the type and also the value. Okay, and we can also like test A. So I can put it as, for example, int, and again I can print this part out. I haven't been using Windows for some time, so yeah, probably my typing speed is not that fast, and actually I'm using my laptop. So without a keyboard, so probably a little bit slow. Just bear with me. And if we run this, basically the both printed out outcome should be the same. You see, int1 and int1. Probably need to put something, but yeah, I believe you get me. So here it actually redeclares this kind of variable, right? So I declare it as an integer. So probably you would like to ask again, okay, though we know that, okay, the type here is the interface, right? But the Golang actually did another transformation for us. Golang is awesome. It just always helps us to do all the dirty works. And here I just assert it as a type of int. So probably you would like to ask, like, okay, what's the implementation for this, right? We already know that task is type of int as printed out here. So this is very crucial, since in the future, probably you will have a function with, for example, like, how to say, variable 1, and you're gonna have an interface, right? And the interface actually has multiple interface. So that is what I'm going to talk about later. So just like Struct, you can actually have other kind of interface inside. So that's called another inheritance. And in that case, you just can't put in here anymore, since the type of variable 1 here just doesn't have any the type of int, string, etc. So a very direct way I test it is if I run this, it will actually say it is int, it is not string. And therefore in the future, if our type can only have the interface, we only have interface and interface. And in that case, we have to do the assertion in order for our Golang to know what it is. Alright, the last part I would like to talk here is the inheritance for interface. So previously we talked about inheritance for the struct, but here I just want to talk about interface. So I just clean it up a little bit. So I have a sayer and what else? Footer, probably. And I know footer is not a good word. It's not actually a word, but I just put it here. So next we also need to define several other methods for cat and dog. So food, cat loves fish and food, dog loves buns. Okay, so here we can find food is because we just define it as interface of Sayer here. So Sayer only has say, but it doesn't have any other stuff. And in order to have the food here, we can put footer as another variable in the interface. So we are actually inheriting footer, the interface, into the Sayer interface. And now if I run again, you can see, okay, I have a food here. So I can basically run it to just prove you I'm not cheating. Okay. So it is cat, it should be meow, and it loves fish. Okay, great. So probably you say, okay, this is a little bit ugly. So is there any convenient way to do this? Because these kind of inheritance is not elegant. Sure, I'll satisfy you, sir. So we can actually have another interface, probably just animal. All right. So this animal will include all the habits for animals. So for example, I can have Sayer and I also have footer. Cool. And here I want to just declare a Sayer animal, and I just declare as animal. And you can see both can be called. Great. So I've already talked about the inheritance for the interface as well. Cool. So this is just like a very basic and introduction to both the usage for the both interface and also the struct. If you have any questions or comments, please feel free to leave them below. I think in the couple of videos later, I will talk about some more advanced level. Hope to see you in the next videos.